Howdy folks, Mr. K here with a online video about mixtures. So far we've talked about this thing already, the periodic table, and I told you in class that everything in the universe is contained within the periodic table. But what about other things that you don't see in there? Is there a box on this table for plastic? Is there a box on this table for air? Is there a box on this table for steel? If you look close, you won't see things for that. That's because there's more than just pure elements in this world. There's also things called mixtures. And by combining together elements, chemically we create compounds, and then by combining different compounds and elements, we create mixtures. For example, let's say I had hydrogen, which is an element up here, and I took oxygen, which is an element over here, and I combined them together chemically. When we do that, we get the very important thing for us, water, H2O, which is a compound. I could also combine this compound, water, with another compound, salt. But I can't chemically combine those. I can mix them together, water and salt, and I get salt water, which is a mixture. So, you can divide all matter into two major categories. That which is pure substances like elements and compounds, and things that are mixtures like pizza and steel, which is a mixture, and hamburgers. All of these different things are mixtures. They're made of elements and compounds, but they're combined differently. So let's look at the pure substances first. So, pure substances are things with only one type of particle. One thing that is a pure substance is an element. Elements have only one type of atom in it. A particle can mean several different things. It could mean atoms, molecules, compounds. It's just very small things we can't see. Atoms are particles. All atoms are particles, but not all particles are atoms. So elements are particles that are made of only one type of atom. They're the things found on the periodic table. If you're given a name of something and it's on the periodic table, then it's an element, like oxygen, iron, hydrogen. Notice, they all have chemical symbols. An element has a chemical symbol. Compounds, on the other hand, are when you combine elements together chemically, meaning you have to do a chemical change to change it into something else or to get the elements back. Remember, in a chemical change, the composition and properties have changed in the substance before the change and after. So you have two elements. For example, sodium is very reactive and chlorine is very reactive, but when you combine them together, you get the compound NaCl, which is not reactive. To get this sodium and chlorine back, you're going to have to do some sort of chemical change to get it back. Compounds are chemically combined elements. They're also when they're chemically combined, they combine in specific ratios, which are these numbers down here in the chemical formula. Examples of compounds are sugar, salt, and water. Notice all of these can be written in a chemical formula. Elements have chemical symbols and they're found on the periodic table. They're made of one type of atom. Compounds are chemically combined atoms that have chemical formulas. Now, when you mix together different elements and compounds, you end up with mixtures. The difference is that a mixture is physically combined. That means you can undo it with your hands or tools. You don't need a chemical reaction to take apart a mixture. And mixtures can be divided into two major categories. Homogeneous, homo meaning same. So a homogeneous mixture looks constant throughout. You don't see any like pieces sticking out of it that don't look like the rest of it. It looks the same throughout. Typically they're clear solutions or shiny metals that look, constant throughout. Examples of homogeneous solutions would be salt water and Kool-Aid. When you mix that stuff together, you can see right through it. Maybe different colors, but you can see right through it and it looks the same throughout. You can also separate it. Remember, we separated salt water by evaporating it in class, which, remember, evaporation is a physical change, and you can undo a mixture because they're physically combined. Heterogeneous mixtures are mixtures with different parts in them. Remember, hetero means different. You can see different parts by just looking at it. Like, for example, muddy water. When you look at muddy water, you can see little bits of soil in the water. Pizza. When you look at a pizza, you can see pepperoni and cheese and different, the crust, everything looks different. Or soda. When you have a soda can, there's little bubbles in the soda can. You see gases within the liquid. Heterogeneous mixtures do not look constant. They look different throughout. And in fact, we separate out heterogeneous mixtures into two further categories. The first one is a suspension. Suspension have extremely large particles. Like, imagine a snow globe. At first, it's all little snow is settled at the bottom. But then you shake it up a lot. And then, so all the snow starts floating around in it. But if you just set it back down, the snow will eventually settle to the bottom again. This is an example of a suspension. They have extremely large particles that don't stay suspended in it. They fall to the bottom. There's also colloids, another type of heterogeneous mixture. Colloids have large particles, but they're not so large that they fall to the bottom. They're able to stay up. But when you can tell it's a colloid if it looks murky and you can shine a light on it, and when you shine light, it causes the light to scatter. If you've ever been in a smoky room and shined a light in there, you could see like there's the main beam of light, and then there's like little dimmer beams of light coming off your main beam of light. That's what I mean by light scattering due to a colloid. A smoky room is a colloid. That smoke stays suspended in the air of the room. It does not fall to the bottom, and when you shine a light there, the light scatters. Okay, folks, that's a brief explanation of the difference between elements, compounds, and mixtures. I will see you in class.